All right, so I'm going to start by defining a few of the terms. So the Michaelis-Menten equation describes the um, reaction of enzymes with substrates. And so the enzyme and substrate join together, E plus S, to create the enzyme substrate complex. Um, this can be formed. So the formation forward reaction is the constant K1. Well, and it can also be broken down or dissociated, and that is the constant K negative 1. The enzyme substrate complex breaks apart and creates the enzyme plus product. So in the beginning, I'm going to focus on the beginning of the reaction. So in this beginning, no product has been formed. I also want to define Vmax. Vmax is the maximum velocity that an enzyme can react with a substrate. Um, and I realize this is pointing at my paper, but that is the maximum amount of material that an enzyme can deal with at a given time. And then Km is also known as the Michaelis constant, and Km can be calculated by dividing Vmax in two, and it is also represented by the terms K K negative 1 plus K2 over K1. So the dissociation over the formation gives us Km. So to start deriving from where it was left off, on the assignment, we have the instantaneous rate of reaction where time is approximately 0. Again, very little product here, so we're going to be dealing there's really a product, but we will talk about K1, which is formation, minus K negative 1, minus K2, all times the enzyme substrate complex and or enzyme substrate concentrations. Okay, so we have the spontaneous rate of reaction for the enzyme substrate complex in step 1, where it's equal to 0. And so at this time, and I'm just reiterating what is on the paper, K1 times E, or concentration of enzyme, times the concentration of substrate, minus K negative 1, times the concentration of the enzyme substrate complex, I'll say ES complex for the sake of shortening it, minus K2 times the ES complex is equal to 0, equal to the instantaneous rate of reaction when the substrate and complex are interacting. From there, we can separate out the equation to give us Km, or to find Km, but then to also find the concentration of the enzyme substrate complex. So we would do ES, the concentration of the ES complex times K1 times the substrate concentration plus K negative 1 plus K2 is equal to K1 times the total enzyme concentration times the substrate concentration. From here, we can isolate ES, and that's going to give us an equation to put into the actual and create the actual Michaelis-Menten equation. So we see that the concentration of the ES complex is equal to K1 times the total concentration of enzyme times substrate concentration over K-1 times substrate concentration plus K1 plus K2. Then we factor out K1 by multiplying by the reciprocal. So 1 over K1 over 1 over K1, which gives us the ES concentration equals the total enzyme times substrate concentration over substrate concentration plus K-1 plus K2 over K1. We're getting closer to actually creating the enzyme substrate complex. See, this was in the way. And the now it's time to focus on K2, where we're creating product. So at the instantaneous rate of change product, we'd have K2 times ES, or the concentration of the enzyme substrate complex. So in the previous step, we actually had the equation for ES. So we'll use that to move along. So that would be K2 times the total concentration of enzyme times the substrate concentration over S plus K-1 plus K2 over K1, which actually is Km, so I'm going to do that again. So K2, which is also called Kcat, is the turnover rate of the enzyme, and that is the number of, or the amount of material that the enzyme can work with and turn into product. So Kcat times total enzyme concentration times substrate concentration over substrate concentration plus Km is the velocity of the enzyme. And so actually, one other special thing, and for velocity I'll do V naught, that was also on the assignment. And so V, we want to find V max, which is actually the maximum velocity of the enzyme. So it's when all of the active sites of the enzyme are occupied by the substrate. And so this is the maximum amount of action that this enzyme can handle, and that is Vmax. Again, maximum velocity, and that is actually represented by Kcat times the total enzyme. So again, we can simplify the variables in here. So it would actually be V naught equals V max, because we see Kcat times enzyme total times substrate concentration. So the substrate would still remain. So V max times substrate concentration over S substrate concentration plus Km. That is the Michaelis-Menten equation. And so I've demonstrated that Vmax is Kcat times enzyme total, which I substituted into the equation. I also stated that Km is K-1 plus K2 over K1. Again, substituted that. Km is the Michaelis constant, and describes the formation and dissociation of the enzyme substrate complex. It is half of Vmax, or Vmax divided by 2, and Vmax is the maximum velocity at which an enzyme can react. So that was my derivation. Thank you.